Yeah. I asked Kevin. Kevin Thull is the person who does all the recording. I said, point that way. Take this picture. But anyway, so yeah, my name's Deep Dive into Front-End Web Performance. My name's Mike Herchel. We're going to talk a little bit about why you want to make your web pages fast, what that even means, because it's kind of ambiguous. Quick rundown, we're going to talk about how browsers work, talk about how to measure that, and we're going to give tips and tricks and stuff like that. This is me. That's my daughter, and that's Dexter. He's sweet. So I have a coworker. His name is Matthew Tift, and he asked this question on a call one time. He's like, "Why do we even need to make this so fast? You know, I'm doing like all these little tweaks." Well, Matthew Tift, 53% of all site visits are abandoned if your page takes too long. There's tons of statistics like this out here. This is a slide from several years ago. A Walmart engineer put this into their slide. They talk about conversion rate, which is the red line, versus the time it takes for the page to load, which is like the x-axis. And you can see that the longer the page takes to load, your conversion rate dramatically drops, right? And there's all types of stuff. There's all types of stuff that says, like, if your mobile site's load in 5 seconds, you earn more ad revenue. And it's an accessibility issue. Marcy Sutton, who's an accessibility advocate that is completely awesome, says that for screen readers, slow websites exacerbate visual content streams, and while an auditory progress counter struggles to reach 100% so the page can be consumed. I should have used a shorter quote for that. But to me, it comes down to apps versus the open web. I'm a big believer in the open web, I think. But if your websites are slow, people are going to gravitate toward apps. And apps are inherently built on a proprietary platform, and you have to pay an Apple or Google tax to get the apps installed, and it's just bad, right? So that is like the general consensus. You need to make your website fast. But I feel like since you're here, I'm probably speaking to the choir a little bit. But let's get into some details. So let's talk about what is fast. Check out this animation. So what is fast, right? Let's talk about some performance metrics. Like what does it mean? Is your website, there's when your website loads, when you can start clicking around, when the last thing loads. What do you even measure? There's stuff like time to first byte, time to first meaningful paint, time to first interactives, the speed index. You might hear these terms, like if you watch any of these presentations from like the Google Chromium team, or you look in your audits panel, and within Chrome Developer Tools. I'm going to talk a little bit about this right now. And I'm trying to go fast too, by the way, because number one, it's about speed. Number two, I have a lot of content. So let's talk about time to first byte. So the time to first byte is basically from when you begin that navigation, you click the link, until that first byte hits your computer, So if delays here can indicate like some type of back-end performance issue, effective caching can help here. Drupal has like pretty awesome caching system, but caching can help. And then something that's really awesome is CDNs, a content delivery network, of course. A content delivery network positions your cache physically closer to where you are, which you have a hard limit on the speed of light. It can't go faster than a certain amount. So by positioning it closer, the website will load quicker. So that's pretty awesome. When I'm going to show some examples of this a little bit later. Like we're going to have like some demos, but you can see this is the performance panel in Chrome Developer Tools, and you can see like as this website loads right here, which you can recognize that website with the screenshots. You can see when that first byte first hits the computer right there at about like a little under a second or so, and that is the time to first byte. Right? So there's another metric that's called time to first meaningful paint, and it's honestly kind of pretty much what you think it is. It's like when that primary content is first visible on your page that you're loading. You know, it marks the paint event that follows the most significant change to layout. If you want to get a little bit more technical, but it's still a little bit ambiguous. You know, like what is the most meaningful thing on the page? A lot of times it's pretty straightforward, but sometimes it can't be. If you're looking at your developer tools, you can see that right when that font loads and we can see maybe, you know, some content there. I would call that the first meaningful paint. So for the Drupal GovCon site here, we're looking now, no, was that like 1300 milliseconds or something like that. You have things like another metric that is very, very important is called time to interactive. So have you ever like gone to you know, a mobile site and the page loads and you start like hitting the menu button and it's like it doesn't do nothing and you're like, what the hell? That's because the website's main thread is still busy and it's trying to like figure stuff out. It is not yet interactive. So time to interactive is basically when you can start doing stuff. You know, your load is finished, the main thread work is done, and it's consistently interactive. And if you're looking at the performance panel here, you can see that main thread work right there, and at some point it just drops off, and at that point you can start working, right? So there's a metric that takes into account everything. It's called the speed index, right? It's calculated, and it's kind of like the average time in which the visible parts of the page are displayed, if that makes sense. Another way to say that is how quickly does the page approach visually complete. And you're going to see like a number, it's going to be in the thousands, and it's basically the time that it takes for the average pixel to paint. This is a image taken from a document. You can see the URL before that kind of explains the speed index, and you can see like that top row approaches visually complete quicker than the bottom row, even if they might be visually complete at the same place, which means that the first row is going to have a higher speed index. And the speed index is calculated value, so you get that on your Audits tab, and I'm going to kind of show that a little bit later. So as far as order, in my opinion, and this is kind of an opinion, right? Opinion is the speed index most important because it takes into account everything, but time to first interactive is like very important because that's like also takes into account everything before that. But that's kind of it. So we have so at this point we know why stuff needs to be fast, right? And now we know what that means, right? We know what a speed index is. We know, hey, this is time to interactive. When you can start clicking around, you got how when the web page is visually complete. But how do we get to that point? How do we measure that? How do we get those values, and how do we affect it? You know, positively, obviously. We could probably affect it negatively if we wanted to, but who wants to do that? So let's talk about how browsers work. Who here is like a front-end developer? Any back-end developers? All right. Who here is just hanging out? You guys can all go. I'm just kidding. For the recording, everybody here is just hanging out. So browsers will, of course, download that initial index file. They start parsing it actually as it's downloading, which is pretty neat. Starts prioritizing everything in there. And so let's talk about how it starts prioritizing, right? So there's 4 levels of priority. That is very complicated. Highest, high, medium, and low, right? That sounds very complicated. So the highest is basically the initial document, any type of fonts, and your CSS. All of that stuff blocks the rendering of the page. So if you have your fonts, or you don't have your CSS or your initial document, the page won't render after, like, until you have that network timeout or something like that. High priority is you have script tags that appear in the head, and any type of like network resources like API requests, which is XHR, which stands for like XML HTTP requests, but it doesn't have to be XML. Medium is like script tags that might be like down in the footer. In Drupal, when you add your JavaScript, you can tell it to show up in the footer, and that stuff comes in at a lower priority and doesn't get parsed to the very end. And then you have like stuff like images. Images are very low priority because they won't block your layout. They'll affect the layout, but they will not block the layout. So your browser will download those last. You can now look at that. If you go into Chrome Developer Tools and you go to the Network tab, you can see there is a priority tab there. That priority tab does not appear by default. You have to kind of add it in there. But you can add it in there and you can kind of see that priority as things come in. And that gives you a little bit of clarity on what the browser's thinking as it's starting to pull stuff in there, which is pretty neat. So we have all this data coming down from the network, and then the browser's reaching out and grabbing other assets. So the next thing it does is it starts parsing and executes CSS and JavaScript, right? So it'll completely parse and execute all the JavaScript that's in the head that does not have the async or defer attribute on it. Now, like if you look at your script tags, you can within your script tag you can add an attribute called async or defer, and those will basically tell the browser to either run that script asynchronously or defer it. I honestly don't know if there's a difference, and I probably should, but they both seem to do the same thing for me when I look at how it renders. But it's almost the same thing as putting them into footer. And so at this point it constructs what's called the CSS object model, and that's just basically a big object, and it gives you an idea of like how your styles cascade down, right? Because CSS is cascading style sheets, right? But it creates this basically a big object, and it parses it, and it puts everything into this object. And it creates, it also at the same time it creates the DOM, which is a document object model, and it does basically creates a big object of that too. And it's doing this all like super fast, as it's pulling this data, it's kind of doing it synchronously if it can. At that point, it will combine the CSS object model and the DOM, and it creates what's called the rendered tree. And the rendered tree is slightly different than the DOM because it won't have stuff that's like displayed none or something in there, And at that point, you have all this data in there, and it creates that hopefully pretty quickly. And it does, so at this point, it does layout, which if you're in like Firefox, they call it reflow for whatever reason. The browser calculates how much space it takes to put the elements on the screen, and it calculates where to put the elements in relation. It's an expensive operation, and when I say expensive, it takes your computer a little bit of processing power, a good amount of processing power to do all this. So you ideally want to just do it once. Now, if you're doing animations, sometimes you're affecting the layout and you're not doing it once, but you need to keep an eye on it. So this is a video from... Is it going? No, it's not. So there's supposed to be a video here, and the video is like stuff like popping in. Like imagine if like, if you will, there would be like squares popping in and stuff like that. Why isn't that showing up? Oh, there it goes. I have to click. So this is, an idea of like basically how browsers do layouts, and you can kind of see how it's calculating stuff, putting it in relation to other stuff, and etc. Of course, it does that like pretty quickly. After it has the layout, it goes to painting, and painting is just basically the process of filling in all the pixels, right? So you have stuff like text, colors, images, borders. It's also a very expensive operation. But afterward, you have compositing. So like imagine, if you will, you have multiple layers, like multiple like Photoshop layers in Photoshop, and you can move one layer around the other pretty easily. But if they didn't have, if you didn't have the one layout or the multiple layers, you would have to like draw underneath the other one as you move one around, which would be a lot more expensive and difficult to do. So compositing is a relatively cheap operation, and it is basically the browser moving around different layers and putting them on top of each other and actually writing them to the screen, and at that point you're seeing stuff, right? So that's like, in a nutshell, how browsers work, right? So there's a lot of things you can think about optimizing right there. You can think about, all right, we optimized network downloads. You want stuff to come in quick, obviously. You can optimize maybe the parsing of the CSS. You want that to be able to parse really quick and generate the CSS object model and DOM and, your render tree pretty quickly. And then if if it's doing layout, you only want to do that layout once. You only want to do the painting once. And then compositing, if you are animating, you want to make sure you're animating these composite layers so they can move around without like basically making your computer cry. So, I'm going pretty quick. Any questions off or anything? Is everybody like kind of going into this? I see a bunch of people nodding their heads and cutting their throats. So, we're going to start measuring this. I'm going to show you like a lot of this stuff within developer tools here, and we could probably. So I'm going to open up Chrome, and I am going to go. I think I will pick on like maybe the GovCon website, and I'm going to use Chrome Canary here. And I like using Chrome Canary. Hold on, I'm going to mirror my screens. I like using Chrome Canary for this type of stuff because if you have extensions installed, like I personally have like a password manager, I have you know, an ad blocker and stuff like that, that will affect, you will see those when you're profiling. So I like to use Chrome Canary, and it will not have those extensions installed because I never installed them. So can I click on this? You'd think you could click on that. Okay, so you guys have all seen this website, right? Pretty good website, pretty quick. The people who did it are completely awesome. So what I'm doing is I'm opening up Chrome Developer Tools, and we're on the Elements tab where we can start affecting stuff, but we're going to go to Performance right here. Performance tab is my favorite tab because it's just like you can drill down, you can learn about how the browser works. So what I'm going to do is I'm going to hit this little icon right up here, and it is going to reload and hopefully not take too long, and then we're going to see this awesome profile right here. Now this is really quick, so let's kind of take a quick look. Let's Command plus this. Man, look how quick this is right here. So we have our time to first byte and something like 100 milliseconds, and the whole page load is like under there. That's almost too quick. I just want to do this again. I'm guessing the website's probably located really close to here, since the time to first byte is really close. But let's kind of take a look at this. So the first thing that we're going to see up here is we're going to see in all the purple we see layout. The blue is rendering. The yellow up here is JavaScript execution and parsing, and that's about it. This is almost too easy, but let's kind of just take a look at this, and we can kind of we can get into. I'm going to go back to the initial profile. It gives you screenshots right here, so when you can see your like time to first byte and everything is. Let me go to a slower website. I wonder. So I'm an organizer for Florida Drupal Camp, which is, in my opinion, the best Drupal camp ever. And maybe our website's slower. I hope it is. There it is. It seemed a little slower. Look, it has a video. All right, so let's go to Performance, and I am going to clear everything out. Let's reload this. Oh, our website's way slower. This is awesome. All right. Like, it's still not bad, you know. We got like, all right, we got a layout event going on over here, but you can kind of see everything kind of happening right here. So, like, the first thing you can see is like you can see the right here's where it. I had the page loaded before, so those were the screenshots of the prior load, and at that point you can kind of see how the placeholder image comes in and the logo gets loaded. The fonts get loaded and all that type of stuff right here. If you go to the network tab right here, you can kind of see how everything's coming in. If you expand and contract this, you can actually see all these network requests coming in right here. So here they are. You can see the first thing that comes in is the high priority stuff. So the first thing that we have is like, we have the index file. You can see the CSS files coming in. There's JavaScript files coming in. And at that point, you start to see these low images coming in, right? These low priority images. So that's basically the screenshot, or that's basically the kind of a demo. So I would say, like, where my mouse is right here, this is, where are we getting time to first byte? You're getting time to first byte right around 600, like right around here. Then we have a gap that we could troubleshoot if we had time. And at that point, we have time to first interactive, I would say like under 2 seconds right here. And if we go to the audits tab over here, and we run audits, we could do a performance audit, and we do this, we could see the speed index. And I think I'm doing that in my slides, so let's just kind of hit play right here. Yeah, so audits, right? So this should be pretty quick right here. I am just going to do not, by default, it will throttle down to 3G. In the name of time, I'm just going to kind of do no throttling, and you're going to kind of see how this works. So within Chrome Developer Tools, you can do like tons of different audits, including accessibility audits, SEO audits, speed audits, and it does Lighthouse audits. Lighthouse was a plugin for Chrome that was mainly geared towards single-page applications and stuff like that. But it's kind of interesting. It talks about it can do like service workers and stuff like that. It can 100. That's a little bit ridiculous. We can maybe do that again, and this time do like no throttling or a little bit of throttling. But we should see a speed index here, and the speed index will give us the amount of time it takes, you know, for like the average pixel to render and all that type of stuff. And it gives you like all these cool little tips as it's going. I'm gonna take a drink of water. Has anyone learned anything yet? No. Alright, speed index, yeah, 6400 is kind of low. You can see we're getting a really slow performance because, you know, this is 3G and stuff like that. But it gives it's just kind of a general idea. So for people, like if you have any type of DevOpsy people in here, you can install like Lighthouse plugins and stuff like that through Node, integrate them into your continuous integration pipeline, have that, you know, pipe it back to your pull request, and you can just have this whole integration stuff like that. That's pretty neat if you're into that type of stuff. Man, so yeah, we're gonna be in February, by the way. We don't have a date yet. So let's talk about like optimizing. Like, so at this point, we know why speed's important. We know how browsers start to do this, and we know how to measure it. But how do we affect it? Like, what are some common things that we can do to actually make our websites faster? That's the goal, right? And by the way, check out like all my cool graphics of the SR-71 Blackbird, which is like the fastest airplane. I'm proud of that. So, use less bandwidth. That's kind of pretty straightforward. But all right, so what does that mean? Well, you can limit the use of large images, which means using responsive images. Drupal supports responsive images out of the box, and what responsive images are, if you have different screen widths, it will serve different images to you, and that's really important because if I have my big ass iMac up here and I want to see this crystal clear image for my background, I don't need to load that same image if I'm on my phone. Because my phone's a lot smaller, I'm not going to notice that detail, and I also don't want to download this 3 megabyte image. So with proper configuration, Drupal out of the box will serve a different image to smaller screens. It's pretty neat. And there's tons of resources out there to do that, but it's a little bit out of scope of this. You want to limit network requests. So this is a little weird. There's a newish protocol called HTTP2, and so the way that the HTTP1, the protocol that most of us use, works is, for every single request to the server, has to reach out, has to say, hey, how you doing? This is me. Please send me down this file. And it does that, and it only does 6 at a time, per domain. So if you have like one domain, it pulls down 6 files, and then like as those finish, it can start pulling down more. That's a problem if you have a server that has like hundreds, or a website that has hundreds of assets. And so that's important. With HTTP2, which is a newish protocol that's supported on like a lot of platforms, but that does what's called multiplexing, and it starts pulling in all the stuff at once, and it can be a lot quicker, especially on like high bandwidth situations. you can see like right here, I think we're using HTTP1, right? Yeah, so this is like the Lullabot website. Oh wait, no. You know, this is me identifying a large image. So this is the Lullabot website, and we had this like 1 megabyte image that was just like a little thumbnail. And it's, you know, the reason why I'm putting that up there is because we know what we're doing, but sometimes stuff sneaks in there, and there's ways to keep an eye on it. You know, as I was saying right there. So yeah, here's just, you can sort by these columns, which is what's happening right here. So just sort by this, look at your assets, figure out, is that really needed? Is that worth a megabyte to download? That's something that's like almost kind of basic, but it's kind of important, which is why I threw it in there. I want to talk a little bit about the purple pattern. Purple stands for push, render, pre-cache, lazy load. So pushing means actually like pushing, like within the HTTP2, you can do what's called server push, and server push will say like, I want you to download these resources initially, and so it'll push down those critical resources initially. Sorry, I'm having trouble pronouncing. Then it will actually render the initial route, which is basically says make the web page appear. And what's really cool about the purple pattern is it pre-caches the remaining routes. So what you can do, and what it does is like, so if you have a hyperlink that go to this page, that page, it'll pull in the data for this. So when you do click on it, it loads instantaneously. And then lazy load and do anything else on demand. A platform or a system that I use for this and that's really awesome is called Gatsby.js, and I don't think I have them in here. Yeah, it's called Gatsby.js. It's a React-based static site generator, and it makes things like this pretty easy out of the box. The creator of Gatsby did a presentation at the Couple Dev Days, which was I think last weekend up in New York City, and those slides are and videos probably online somewhere, but. I feel like that's really worth mentioning because it's kind of a new, what do you call it, paradigm, which sounds like, but it's a really cool way to do stuff, and it makes your websites feel like instantly fast. Optimizing the network bandwidth. So we talked about doing all that. So here is, I think, the video of me looking at HTTP2. So you can see over here on the right hand side, all these assets are kind of coming in synchronously. They're all coming in at the same time, and opposite of that is the Lullabot website. We are still on HTTP1, and you can kind of see we have things kind of staggering, waterfalling in, and it's a little bit slower. So that's something to keep in mind if you can do HTTP2, that will help everybody out. Oh, so here we are. So this is a website that I worked on several years ago, the Sci-Fi Network. And if you look down here, it has 356 network requests. And a lot of these are ad trackers, which load more ad trackers and stuff like that. And if you can filter using this little filter, where's my little mouse? I don't even know where my mouse is. You can filter using in the top left, and you can type in like domain www.sci-fi.com. If you were to do that, the amount of requests that are from that actual origin domain are probably like in the neighborhood of like 60 or 70, which means that you have all these requests coming in from ad networks that are really kind of eating up the majority of the bandwidth and taking up the majority of latency, and it dramatically affects the time to first interactive. That's a rant. So resource hints. Who here has used resource hints or kind of knows what they are? A couple people? This is something I want to see. So one of my coworkers, Joe Schindler, who's like an amazing, awesome person, told me, Mike, when you give a presentation, concentrate on 2 or 3 things that you want your attendees to take away. This is one of them. This is like super important. So what a resource hint does is it's a tag you put in the head of your document, and it tells the browser to download that immediately. And you might ask, why is that important? Why the browser is going to get to it, right? So in order, like say you have a web font, and I'm using say @fontface to download the web fonts, which means that the @fontface rule is in the CSS file. So in order to figure all this stuff out, the browser needs to download the index.html file, start parsing it, download the CSS file, start parsing it, look at the DOM, see the @fontface rules, see what relates to this, and then start downloading all those web fonts. That's a bunch of steps, and so what happens is your web page will show up, but the text won't show up. Has everybody ever seen that? If you looked at the GovCon screenshots earlier, that was happening there. And the reason that's happening is, like I said, the web fonts aren't showing up. You can fix that by preloading fonts. And what the preloading fonts does is it tells it to download immediately, and then by the time the browser realizes it needs that font, it already has it. And it can render it immediately without waiting for any type of network request. So there's a couple other types of resource hints called, there's one called DNS prefetch, which basically reaches out to the server and does a DNS lookup on it. And that's a little bit more widely supported than preload and preconnect. But what DNS is what kind of relates the domain you're looking up to an IP address. And it usually takes, I don't know, 1/10 of a second or maybe even longer. PRECONNECT is actually really cool. PRECONNECT does the DNS prefetch, but it also connects to the server. And you might be thinking to yourself, well, why would I want to pre-connect to that server? One of the reasons that you might want to is because if you're using HTTPS, which hopefully you are. If you're using HTTPS, your browser has to parse and validate all the TLS certificates and everything like that, which takes a little bit of time. So by pre-connecting to that, you are saving that step later. And I'm going to show some examples of that. So here's preload in action right here. This is the Lullabot webpage. And you can see we preload the JavaScript file right here. And the reason that we preload it is because the actual script tag is in our footer. So the script tag is in the footer, which means it's not going to be parsed until later, but we tell it to start to download immediately. So the web page, the browser will pull in the web page and it'll say, I need this file, I don't know for what, but I'm just going to get it. And then by the time it gets down there and starts, it says, I already have this file. And that right there probably shaved a good half a second off of the loading time of lullabot.com. Pretty neat. And you can see some of this right here. You can see, so this is the performance tab where we were just at, and you can see the second file that's being downloaded right here is that JavaScript file. And after that, you can see some fonts right there too. Pre-connecting, we do pre-connect also. So lullabot.com right now is a decoupled React site that hooks up to Drupal, believe it or not. And so our Drupal site and our API site are of course on HTTPS, and so we pre-connected those so we don't have to negotiate that that security certificate when it's reaching out for the data. And so here you can see an example of the DNS lookup, the SSL connection time, and all of that. If it doesn't do the pre-connect, but if it does do the pre-connect, it basically takes it down. So you're shaving off maybe like 1/4 of a second or something like that, as it is, connecting up to that domain. It's pretty awesome. Yeah. All together. So we did a little bit of work on Pantheon's web page, redesigned some landing pages and stuff like that. And part of the things that we were working with Pantheon is making their front end a lot faster. And so we did that. So you can see up to the top up here, we are preloading the fonts. And something that's kind of important, you can see that cross-origin attribute all the way to the end of the fonts. According to the internet, and by internet I'm talking about a specific article from a member of the Google Chromium team, he said that if it does not exist, the font will download twice. I haven't verified that, but I just added that in there just because. So you can see the fonts up there. And then you can also see, kind of near the bottom, we're preloading images. And the images are basically like the hero background for the home page, right? And so that image normally would be loaded through the CSS background image property, which basically means that the browser has to, you know, parse the HTML, has to download the CSS, has to look at the DOM, figure out what it needs, has to look at the CSS, download this background image, and all that type of stuff. Now, we download that initially, so there's no lag with that background image sliding in. But you can look to the right here, there's a media attribute, and we're loading several versions of that background image depending on the screen resolution, because as I mentioned earlier, you don't want to be loading a large image for a smaller screen. And so that media attribute exists for situations like this, where you can actually say, I want this image between this screen width and stuff like that. And at that point, Pantheon, of course, hooks up to a number of like Optimizely, and they have OLARC for like little chat and stuff like that. So we pre-connect up to those servers, and it speeds things up, and it's pretty nice. So once I said, you know, earlier I said like this is one of the takeaways. You can use this immediately. If it doesn't work, it just doesn't work. There's no drawback. It's not going to break your website or anything like that. And if you look at the browser support here, it's supported by Chrome, Safari, iOS Safari, believe it or not, Edge. Firefox has it coming soon, but this is probably, depending on your particular website, 60, 70, 80% of your traffic right here. So you can speed that up pretty much dramatically just by adding those tags up there, and that's pretty awesome, right? So yes, optimizing your network. Another negative thing that you want to do is chaining dependencies. I mentioned how like, you know, your CSS had to download this, which downloads this. That's kind of chaining dependencies. Sometimes it can't really be avoided, but sometimes it can. And like certain situations, like an ES6 import, you know, pulling in another file which has to wait and then execute, which might pull in another. You know, we have bundlers right now for a lot of different reasons, but this is one of them. And everybody typically use bundlers if you are doing like any type of ES6 stuff. I just want to say that's a good thing. Here is a screenshot of Lullabot hooking up to its API, and this is kind of like a little where the bodies are buried, you know, going right here. So we actually chain multiple API requests here, which is not the best thing to do, but it's happening. So you can see like the one API request triggers another API request, which triggers another API request. It's not the best way to go about things for obvious reasons. And you can see that there's a little gap up there. This is all being fixed, but it's important to be able to identify those issues, and you can kind of see how I did that up there just by like saying, hey, look, there's a little gap, and then we render a bunch of stuff. So that's something keep in mind. You know, audit your own web page. Figure out where your bodies and skeletons are buried, because everybody has them. Rendering. So we talked about network. We're in rendering. How much time do I have? I got 8 minutes. I think we're doing all right. Maybe can have time for a water. All right. So I got a bunch of cool drawings of a SR71 Blackbird. So CSS optimizations. You want to avoid inlining images. Everybody for a little time was inlining their CSS image, which basically would take like your CSS or your image, it would base64 encode it, embed it in like a string of, you know, numbers and letters in your CSS file, and the benefit of that would be your CSS file is cached everywhere, so you have access to these images everywhere. The downside of that is CSS blocks your critical render path, you know? So your images do not. You want your web page to render initially really quickly, and base64 encoding, number one, eats up the bandwidth, and number two, it makes it more larger and more difficult for your browser to parse that. So you want to avoid large style sheets when you can. You know, a lot of this comes down to best practices and componentizing your styles. I have one of my ways that I say that is like a good way to organize your code is make your code easy to delete. If you can delete your code without having to worry about what that's going to affect, you're doing something right. Don't worry about selector performance. I've seen like plenty of talks, mainly from like several years ago, saying, hey, this selector might be a little bit slow. I don't worry about that. Your browsers are very, very efficient at parsing selectors. It is probably measurable at some point, but it is not going to really affect you in the real world. Inline your CSS if you can. So when I talk, you say this bullet is inline CSS for critical path. So the critical path is like everything it takes to render that initial page right there. So what you can do is you can take your CSS for say your navigation and your hero, embed that into a style tag into your head, and then put the rest of the CSS out of the head so it doesn't block rendering. And that will save a couple network requests. That will optimize your website, make it render faster. It's kind of one of those optimizations that takes a lot of work. So your mileage may vary. And I'm a fan of splitting up monolithic style sheets. I have seen style sheets that were over 1.5 megabytes. And what I've done for things like that is try to split them off into multiple style sheets and load those style sheets only when necessary. For example, like if you have styles for code syntax highlighting, only load those on article nodes that actually will use that. And I have a little bug here, but Chrome Developer Tools has a coverage tool and can help identify CSS and unused CSS in JavaScript, and I can show that in a little bit too. Critical path. I just talked a little bit about this, but it's basically all the CSS and everything that's needed to render the initial viewport, and you can load that later CSS somewhere in the body, typically right before the component is loaded. So of course it causes everything to render properly, and then as the browser parses the body, it will pull in those CSS files as needed. Optimizing your JavaScript, that is a huge topic. The main thing I would like to say is the less JavaScript the better. There are certain situations, like a lot of the stuff that you used to use jQuery for isn't necessarily needed anymore. Like vanilla JavaScript can do a lot of the heavy lifting that you used to use jQuery for like cross-browser compatibility and events and Ajax and stuff like that. I don't think jQuery is necessarily bad, but sometimes you just might not need it. And just keep an eye on what you're loading. I've seen many web pages that might have a JavaScript file for a I don't know, a slideshow being loaded everywhere. Load it only where it's necessary. This is a picture I took of the JavaScript main thread execution, which is kind of funny, right? So JavaScript is not multi-threaded. It will just work on one CPU core, and that while that CPU core is doing all the work, all the others are just idling. And there's some exceptions to that, including web workers, where you can offload your processing, your JavaScript processing, but that gets kind of complicated pretty quickly, and it's only useful in certain situations, and it doesn't have access to all the APIs that your main thread does. So in 2018, which happens to be the year right now, you're learning a lot here. The average phone takes, what is it, about a little under 2 seconds to process a megabyte of JavaScript, right? So if your JavaScript bundle size is 1 megabyte, your phone, just to parse it and process through here without really starting executing and doing much, is just a little under 2 seconds. And that's something to keep aware of. What's really kind of illuminating here is look at the difference in the modern phones, like the iPhone 8 and I don't know, the Google Pixelbook and Pixel 2 and all that. It's really interesting to see how much faster those are than your regular phone, your average phone. And it's important to keep that in mind. So when you're like using like my fancy phone that I have right here, I'm holding up like a Pixel 2. The experience that I have is not maybe the same that, you know, my mom or my brother and their crappier phones is going to have, you know. So keep that in mind. Less JavaScript. Identify unused code. Third-party scripts. I talked about third-party scripts earlier. I'm going to talk a little bit more about this in a second. That's the, in my opinion, a very accurate, appropriate use of the poop emoji. Code splitting. So code splitting is a lot of times, like if you're doing like any type of like modern JavaScript frameworks and you're using Webpack, you can set this up to do it automatically. Through Drupal, if you're using like kind of like old school, you know, regular JavaScript, load through a script tag and all that type of stuff. You can do that through the libraries API in Drupal or Drupal add.js, where you only load your particular library for a particular component. There's a method in Twig, attached library, where you can load a particular library within a Twig template, and that's really useful to only load the JavaScript where it needs to be. Within Drupal 7, you have to use Drupal add.js, which can be done like in a modular preprocessor or something like that. Virtual DOM does not fix this. I don't know why I have that there. I think that was a bullet for something else. And profile, learn how to profile your stuff, which I talked about a little bit earlier. Like, if your JavaScript is taking up a very long, if your main thread is occupied for a very long time, learn how to profile it. And there's tons, if you Google how to profile JavaScript, you will find lots of great stuff. And I can actually show some of that too. Man, I want to let's go to the Lullaby website or webpage, since that has. So hi, we're Lullaby. Lullaby's a great website and a great company. So here we are. So we got the time to first byte. You can see is like around under a half a millisecond, which is pretty good. You can see we have some purple layout coming in right here, and at that point, I'm going to show you a couple different things here. Because we're asyncing the JavaScript, and but we pull it in through the the resource hint. You have like these stripes up here, and let me see if I can show you where that is. Yeah, script streamer thread. It will actually parse the JavaScript on a different CPU core, which is kind of nice. Make it a little bit quicker and asynchronously. So you can see right here that this JavaScript file it takes about half a second to parse, and that's before it actually gets executed. But that's going on synchronously with like a lot of this layout operations, which is pretty neat. So at this point, we're getting into actually executing the JavaScript. And if you get into the main thread right here, you can kind of start looking around and evaluating right here. So we have down here we have a flame chart, and this flame chart, like the flame chart will go kind of deep, but what you want to keep an eye out for is scripts that go very long, because this, like, the x-axis of this chart is time. So we want to kind of start, you can kind of start clicking around in here, and all of this right here is optimized and uglified code. But you can kind of click on each of these and see what's happening right here, and you can click on this and you can see like what function is being called. Now, as I said, this is kind of uglified right now, so it won't give you an idea of exactly what this function is, except for it just says TI. But if you're running this in like development mode and your code is not minified or uglified, you can maybe get a better idea of what's going on and like why things are taking a long time, if they are. Getting back to Performance tab, over here you can kind of see we have another layout operation and stuff like that. So that's the gist of that. Identify third-party scripts. This is a fun one. I picked on the Sci-Fi Network a little bit earlier. I might do it again, just because it has a kind of a special. That is not the right, I want to use Canary. The Sci-Fi Network has a special place in my heart because I did work on it at one point, and it's great people and great organization. A lot of third-party scripts. So what I'm going to do is I'm going to go into performance. I'm going to reload right here. And we're just going to wait for this to come down. Now, like as a front-end developer, I don't have a lot to say on like what third-party scripts get loaded. But what I can do is I can identify them and maybe take this to the marketing people and say, hey, this particular script is slowing down my web page by this amount, and here's the proof. And that might hopefully adjust some of this. So I'm gonna go to the bottom up tab on the bottom right here, and you can see right now I'm grouping by activity. I want to group by domain, and so at this point everything is grouped. So I can see like most of the stuff is coming from sci-fi.com, which is good. Unattributed is generally the same. But though I can see that like I have 600 milliseconds of processing time coming in from like adobetm.com. I have about half a second of processing time coming in from moteads.com and ad save protected, and you can probably go down this list right here and see everything that's being loaded right here. So, alright, so I see this type of stuff right here. I see like adobetm.com. I'm going to go, what I can do if I want to do like, say like an A/B test of this, I can go to the network tab and I can say something like domain, Adobe, what was the name of that domain? Yeah, I might need to look at it to see if there was a subdomain in there. I can group by subdomain also. Assets.adobe. So you should be seeing it in here for something.
You start out Adobe.
Yeah, that's a smart idea. I don't know, but there's multiple ways to do this. So what I'm going to do is I'm going to go to request blocking at the bottom, and you can enable request blocking, and you can see I've been playing around with this and I have a bunch of stuff like kind of blocked in here, but I can add that in here, and at that point, now that I have these request blocks, I could reload. And at this point, once you reload, you can see the performance profile of your web page before and after. And these might be off of something different, but let's take a look here. And when you click in here, you can see the previous profile versus the newer profile right here. So you have this visual representation of the processing of your web page before and after. I think I'm going over time, aren't I? Yeah. I know I was gonna. Sorry. Let's hurry up and wrap it up. Key takeaways. Learn how to identify performance issues, optimize your images, and start using resource hints. Make the web a better place. Thank you. If anybody has questions, I don't know, I'll be out there somewhere, or you can ask questions or whatever. Thank you.